Hi to everyone. Uh, Myself here Rajesh, Assistant Professor, working in the Department of Computer Science and Engineering, Erode Secondary Engineering College, Erode. So today this video is going to show something about the CPU scheduling in an operating system. In the operating system, the CPU scheduling is more important topic so that I can put this video for the students community. They should understand about the CPU scheduling, then only they have to easily understand about how the process is running in the computer and how the process is working on the operating system. So that we are having I'm trying to put this video. So now move to the slide about the CPU scheduling. So before going to the CPU scheduling, you know very well about operating system. Operating system is the interface between user and the computer. User can give many inputs to the computer through the operating system, and the operating system going to interact with the user through monitor or through keyboard or through the printer and the speaker, and many paper devices are used for acting as a output device that is also controlled by the operating system. So everything is controlled, the computer is controlled by the operating system. In that operating system, CPU scheduling is one of the important topic. Okay, let's go to the slide. CPU scheduling. Before deeply discuss about the CPU scheduling, we have to know about the basic need of CPU scheduling. Scheduling. What is scheduling? Scheduling of process or work is done to finish the work on time. So why we need the scheduling? We have to complete the process or work is on time. We have to complete the work or process is on time. So that also one of the reason we need the CPU scheduling. CPU scheduling is a process that allows one process to use the CPU while another process is delayed due to unavailability of any resource such as input, output, etc., thus making full use of the CPU. Yes, here the CPU is already utilized by some process. That process is come out from the CPU for some reasons like input or output or any event. That particular process come out from the CPU. On that time the CPU is ideal. On that case, any one of the new process can able to use the CPU. So that is also possible by the CPU scheduling. Okay, if any process can reside in the CPU, if there is no process inside the CPU, now another process can use the CPU. That's called as a CPU full utilization. We never leave the CPU in the ideal state. So that is also one of the main reason for main thing achieved by the CPU scheduling. The purpose of the CPU scheduling is to make the system more efficient, faster, and fairer. Yes, of course, without the scheduling, we never achieve the efficient, we never achieve the faster. So with the help of the CPU scheduling, we have to achieve the efficient performance of the CPU and faster the CPU is working and the CPU working in the fair manner. So these are all the benefits, and these are all the things we have to achieve with the help of the CPU scheduling. And also, whenever the CPU becomes ideal, the operating system must select one of the process in the ready for launch. Yes, you know very well. We are having the thing is called as a ready queue, running queue, new queue. Like a lot of queues are there for the process. Whenever the CPU ideal, whenever there is no process inside the CPU, the operating system immediately select any one of the process from the ready queue to put the process into CPU. For that, it can select the process from the ready queue. Yes, those programs are ready to run. We have to put that programs into the ready queue. So the operating system is going to select the process from the ready queue to running, because we never allow the CPU in the ideal state. Whenever the CPU becomes ideal, the operating system must select one of the process in the line ready for launch. The selection process is done by a temporary CPU scheduler. The scheduler selects between memory process ready to launch and assign the CPU to come to one of them. Yes, we have to apply a lot of schedulers to select the process from the ready queue. We are having a lot of schedulers like long-term scheduler, and we are having some schedulers are there. In upcoming slides we are going to discuss about that. So with the help of the scheduler, we have to choose the process from the ready queue to running, or from the ready queue to CPU. So these are all only possible when we are having the scheme called as a CPU scheduling. Without scheduling, we never disciplinedly schedule the process from main memory to CPU. We cannot move the process from main memory to CPU. It will be very difficult. So that we are having the scheduling. So this is the importance of having the scheduling. Okay, next CPU scheduling. Here are the reasons for using scheduling algorithm. So why we have to use this? We are having a lot of scheduling algorithms. Okay, why we need the algorithms? The CPU uses scheduling to improve its efficiency. Yes, how we are going to take the process from the ready queue to CPU? We are applying a lot of techniques to take the process from ready queue to CPU, or we can take the process from memory to CPU. So we have to improve the efficiency of the CPU. Okay, we have to improve the efficiency of the CPU. For that, we have to use more number of algorithms for improve the efficiency of the CPU. Helps you to allocate resource among competing process. Yes, how the resource is very less, but number of process is there. So how we are going to allocate the resources to the process effectively? For that reason, also we are need the scheduling algorithm for allocating the proper resources to the process. Then the maximum utilization of CPU can be obtained with the multi-programming. Yes, of course, if you go for the multi-programming, on that time we have to use the CPU properly, or we have to use the CPU in the maximum basis, like a maximum utilization. So we are using the CPU very maximum in the case of multi-programming. So we have to do it with the help of the scheduling algorithm. The process which are to be executed are in ready queue. So what are the processes are in the ready queue? We have to move the process from ready queue to CPU. For that reason also we need the algorithm. We need the algorithm. So that is also reasons for using a scheduling algorithm. Next, CPU scheduling criteria. What is criteria? Criteria, there is a two criteria for the scheduling. One is maximize and another one is a minimize. Yes, some of the things are we have to maximize, and some of the things we are going to minimize with the help of the scheduling. So here we talk about the scheduling, so you should know about what is the use of having the scheduling, having the scheduling in the operating system. So criteria, here we are having a two criteria for scheduling. One is maximize. That means we have to maximize more number of things. Then one side is minimize, that have to minimize number of things. That's there given in the slide. So what we are going to be maximized through the scheduling? Yes, one is CPU utilization and another one is throughput. What is CPU utilization? CPU, already previously we discussed it in the slides. The best performance of the CPU is maximum the CPU used by the process. How maximally you are using the CPU? How long you are going to use the CPU? We never allow the CPU in the ideal state. You have to use the CPU continuously. Is called as a CPU utilization. You have to improve. That is called as a maximize. And also throughput. Throughput means amount of done what work amount of work done in the particular time is called as a throughput. What amount of work done in the particular time is also going to maximize. Throughput means what amount of time we have to done with the specific time. So we have to improve these areas called as a CPU utilization and throughput. So what are the things we have to maximize? Turnaround time. The first one, turnaround time, waiting time, and response time. What is turnaround time? Turnaround time means when you are going to submit your job and the completing the job, that particular time is called as a turnaround time. So you have to minimize the turnaround time, waiting time. When your process is going to get the CPU is called as a waiting time. You have to minimize your waiting time. As soon as possible, the process is going to get the CPU is called as a waiting time. So you have to minimize the waiting time. And also response time. When the process is going to respond, when the CPU is going to respond to your process, that is very important. So that is also here we are try to minimize. So these are all the CPU scheduling criteria: maximize and minimize. In the maximize, we have to maximize the CPU utilization time, and we have to maximize the throughput time. And also in the minimize part, we have to minimize the turnaround time, waiting time, and response time. Before discuss about what is process. Before the process, you should know, you have to know about what is program. The program means we are doing a set of lines, a set of coding done by the programmer is called as a program. All the programs are stored in the computer. After that program, after doing that program, we have to execute the program. For that purpose, we are moving all the programs into the main memory. After moving all programs to the main memory, the main memory going to having all the programs. After that, that program is called as a process. The program is called as a process. What is process? The program in execution is called as a process. The program in execution is called as a process. After moving all the programs into the main memory, then we are going to applying any scheduling algorithm. After that, we have to move the process from main memory one by one, from main memory to CPU for its execution. That's called as a process. In computing, a process is an instance of a computer program that is being executed by one or many threads. It contains the program code and it is activity. Depending on the OS, a process may be made up of multiple threads of execution that executes instructions concurrently. Yes, process means the process is break into number of threads. All the threads are executed concurrently. It's also called as a process. The process means all the activity of the computer is called as a process. All the process is working concurrently. All the process is working concurrently. That is called as a process. Next, CPU scheduling. There are three type of process schedulers. One is a long-term or a job scheduler, and another one is a short-term or CPU scheduler, and third one is a medium-term scheduler. These schedulers, we need this scheduler for scheduling the process from one location to another location or main memory to CPU. For that reason, we need this kind of schedulers. Okay, here again we are going to discuss about what is long-term scheduler and short-term schedulers and mid-term schedulers in the upcoming slides. Yes, what is long-term scheduler? The job scheduler or long-term scheduler selects a process from the storage pool in the secondary memory and loads them into ready queue in the main memory for execution. Yes, we are doing lot of programs in the computer. All the programs are stored in the secondary storage. After storing the secondary storage, we want to execute all the programs. For that reason, we are going to move all the programs which is stored in the secondary memory. We are going to move from the secondary memory to main memory. That is the job of the long term scheduler. We have to move all the programs from secondary memory to main memory or secondary memory to ready queue in the main memory. For why we have to move the all the process from secondary memory to main memory? For its execution. It means what? All the programs are we have to execute. For that purpose, we are moving to main memory. The long-term scheduler controls the degree of multiprogramming. It must select a careful mixture of input-output bound and CPU bound process to yield optimum system throughput. If it selects too many CPU bound processes, then the input-output devices are ideal, and if it is selects too many input-output processes, then the processor has nothing to do. Yes, in this long-term scheduler, we cannot choose more number of processes at the same time. We have to select to process one by one into the CPU, Then only the CPU is going to be act perfectly or rightly. Otherwise, the CPU is going nothing to do when you are choosing more number of programs into the CPU. That is also one of the constraint. We cannot choose more number of processes at the same time. We have to select only one process at the same time is one of the criteria in the long-term scheduler. So very importantly, the long-term scheduler is the first initial stage of the program execution. It's going to move the program from secondary storage device to ready queue in the main memory. That is the job of the long-term scheduler. Next, short-term scheduler. The short-term scheduler selects one of the process from the ready queue and schedules them for execution. A scheduling algorithm is used to decide which process will be scheduled for execution next. The short-term scheduler executes much more frequently than the long-term scheduler, as a process may execute only a few milliseconds. The choice of the short-term scheduler are very important. If it selects the process with the long burst time, then all the process after that will have to wait for a long time in the ready queue. This is known as starvation. This is known as what? Starvation. Starvation means we cannot do anything in that point. From in that point, all the system is going to be hanged, so that we can't do anything in that situation. It's called as a starvation. It may happen if a wrong decision is made by the short-term scheduler. What they are trying to say here means, first, in the first point, the short term, what is the job of short term scheduler? The short term scheduler is going to select the process from the main memory to CPU. That means which process we have to execute next in the CPU, that should be decided by the short term scheduler. The short term scheduler selects one of the process from the ready queue and schedules them for execution. Okay, so which process we have to execute inside the CPU, that should be decided by the short term scheduler. And also, comparatively with the long term scheduler, short term scheduler only executes much more process frequently, because every process only running in the CPU few milliseconds, so that the short-term scheduler is going to handle with more number of process frequently than the long-term scheduler. And also, the short-term scheduler going to select the process carefully about their burst time or CPU time. If you load the process with the longest burst time into the CPU, means all the process should wait in the queue until that existing process completes its job. If the existing process have a long burst time, means the remaining process has to wait on the ready queue, that will lead to the traffic, network traffic. So that we have to choose proper, or we have to choose which process having the less burst time first into the CPU. Otherwise, if you choose any long burst time process into the CPU, means this will lead to the starvation. Starvation means what? We can't do anything. The system is going to hang. All the process waiting outside up to complete the longest burst time process in the CPU. It may happen if wrong decisions made by the short-term scheduler. That choosing is long burst time is means that is called as a wrong decision made by the short-term scheduler. Okay, this is the entire story about the short-term scheduler. And next one, medium-term scheduler, mid-term scheduler, or sometimes called as a medium-term scheduler. So here, what is the role of the medium-term scheduler? The medium-term scheduler swaps out a process from main memory. It can again swap in the process later from the point it stopped executing. This can also called as a suspending and resuming the process. This is helpful in reducing the degree of the multi-program swapping. Is also useful to improve the mix of input-output bound and CPU bound process in the main memory. Yes, of course, one of our process is running inside the CPU. While running the process in the CPU, that process wants any input, or that process wants to give any output, means we have to swap the process, or we have to remove the process from the CPU to main memory. We have to remove the process from CPU to main memory. After complete the job of the process, like getting the input or giving the output, again we are going to move the process from the ready queue of the main memory to CPU. So this switching is, the switching is made by the medium term scheduler. The switching means switch from CPU to main memory, again main memory to CPU, for various reasons, like in various reasons, that is done by the medium term scheduler. That is done by the medium term scheduler. Okay, next, so we discussed about three type of schedulers. One is a long term scheduler, a short term scheduler, medium term scheduler. Next, categories of scheduling. Here we are having a two categories of scheduling. One is a preemptive scheduling and another one is a non-preemptive scheduling. Non-preemptive scheduling. So, what is preemptive scheduling and what is non-preemptive scheduling? Preemptive scheduling means if any one of the process is executing inside the CPU, at that time any higher priority process is requesting the CPU. that existing process from the inside the CPU is comes out from the CPU. It can allow the higher priority process inside the CPU is called as a preemptive. Is a preemptive. We have to allow the process inside the CPU for a particular time, but any higher priority process coming requesting the CPU means the CPU exit the existing process and it can accommodate the new process. That is called as a preemptive. That is called as a preemptive scheduling. And one more category of scheduling is a non-preemptive scheduling. So what is non-preemptive scheduling? Non-preemptive scheduling means we have to allocate the process into the CPU for a particular time. In that particular time, we never allow any new process inside the CPU. We have to complete the entire job of the process only. We have to leave the process from the CPU. We cannot allow at any cost. We cannot remove the process from the CPU. Is called as a non-preemptive scheduling. And here the types of scheduling algorithms. Okay, we discussed about criteria of scheduling, categories of scheduling, and everything. What is the scheduling, why we need the scheduling, what is the importance of the scheduling, everything we discussed it. Okay, now we are having the slide about types of scheduling algorithms. Types of scheduling algorithms. What are the types of scheduling algorithms that are available in the operating system? First one is called as a first come first serve, FCFS, shortest job next, priority based scheduling, shortest remaining time, round robin scheduling, multiple level queue scheduling. These are the types of the scheduling algorithms. Here in the upcoming slides, we are going to discuss about each and every algorithm and its example also. Okay. The first one, first come, first serve. First come, first serve. What is first come, first serve? Everyone knows about this basic first come, first serve. Jobs are executed on first come, first serve basis. It is a non-preemptive and preemptive scheduling algorithm. Whether you have to apply the FCFS in the non-preemptive, whether you have to apply this FCFS in the preemptive algorithm. Easy to understand and implement. This kind of basic first come first service is easily understand about all the users and we can able to easily implement where we have to implement. If you go to the cinema theater, if you are going a first in the ticket counter, you can get the ticket first. If you are going as a last in the ticket counter, you are going to get the ticket last. That is the best example for the first come first service, easy to understand and implement. Its implementation is based on FIFOQ, first in first out queue. Poor in performance of average waiting time is high. In the FCFS implementation is easy, but average waiting time of every process is so high, so high. That is a big drawback in the first come first service. Here we are having the example about the FCFS. Here they are giving certain process called as a P0, namely P1, P2, P3. Every process has some arrival address 0, 1, 2, 3, execute time, and the service time is also given. Okay, so which process we are going to allow into the CPU first? We have to allow the process P0 because its arrival time is 0. So what is the execute time of the P1? 5. So the 0 to 5. Next, which process comes second? 1. 0 after 1. So we have to allow P1. P1's total execute time 3. So that here 5 to 5 plus 3, 8. So which process arrival time is 2? P2. P2 request 8. So 8 plus 8, 16. And which one comes next in the arrival time of 3? P3. So we have to put P3 into the CPU. It requires 6 execute time. So 16 plus 6 is equal to 22. So this is the way for execute the process, or this is the way for putting the process into CPU in the basis of first come first service. Here we have to check about the arrival time only. 0 is the first arrival time, then 1, then 2, then 3. So based on the arrival time, we have to allow the process into the CPU for their execute time. For their, if they are complete its entire execute time, we have to check second one. After complete the 3 execute time of the P1, we have to move the third one. Likewise, we are working in the first come first service. Okay. Next, first come first service. Here we have to find out the average waiting time. So the first one, 0 P1 0, formula is there. Wait time is equal to service time minus arrival time. Service time is 0. Arrival time 0 for P0. 0 minus 0 is equal to 0. P1 service time is 5. Arrival time is 1. So 5 minus 1 is equal to 4. P2 arrival service time is 8. Arrival time is 2. So 8 minus 2 is equal to 6. P3 service time is 16. Arrival time is 3. So 16 minus 3 is equal to 13. So we have to add these four values, 0 plus 4 plus 6 plus 13. We are getting some value divided by the 4. Because why we are dividing by the 4? We are having a 4 process. 0, 1, 2, 3, 4. So divided by 4 we are getting 5.75. Okay. So this is the average waiting time of first come first service. Next algorithm, shortest job next, SJN. This is also known as the shortest job first or SJF. This is a non-preemptive preemptive schedule algorithm. We have to apply both non-preemptive and preemptive in the SJN. We have to apply the SJN in non-preemptive. We have to apply the SJN in the preemptive scheduling algorithm. Best approach to minimize the waiting time. The FCFS is maximize the waiting time. The average waiting time is so high in the FCFS, but in the SJN, best approach to minimize the waiting time. Easy to implement in batch systems where required CPU time is known in advance. Here in the shortest job first, we must know advancedly about the CPU time. Then only we have to calculate and we have to put the process into CPU. Impossible to implement an interactive systems where required CPU time is not known. Yes, if we don't know about the CPU time, we never implement this process in the SJF. You must know about the CPU time. You must know about the CPU time. Then only we have to solve or we have to use the process in the SJF. Otherwise, we cannot use the process in the fashion of SJF. The processor should know in advance how much time process will take. The processor or CPU both are equal. The processor should know about the process total time to take into the CPU. That is also one of the advantage of the shortest job next. Here we are having the example. Here we are having a four process, namely P0, P1, P2, P3. Arrival time of process is likely 0, 1, 2, 3. Execute time also given in the table. So how we are going to pick the process from the table? How we are going to choose? How we are going to select the process? So see the execute time, the 0, the first one 0, the arrival time of 0, which process coming? P0 is coming in the arrival time of 0. So we have to choose P0. Have to choose, sorry, P1. So we are taking the P1 first. You can see the execute time. Which process? We have to choose the process according to the execute time. P0 takes 5 seconds, P1 takes 3, P2 takes 8, P3 takes 6. So which process taking the less time? Obviously P1 taking the less time as a 3 milliseconds. So we have to allow the so we have to choose the P1 as a first 0 to 3. Now P1 is completed. The remaining process is P0, P2, P3. P0 5, P2 8, P3 6. So which one is less? P0 is less. 5 seconds only it requires. So we have to allow P0 5. 3 plus 5 8. After P0 P1 we are having only two process P2 P3. This P2 P3 which one is less? P3 is less. It requires only 6. So we have to allow or we have to choose or we have to select P3 from 8 to 6 is becomes 16. Then and the final one is P2. P2 request 8. We are given on the shortest job next. Okay. So this is the average waiting time of the shortest job. First, we are having the formula service time minus complete arrival time. So 0 minus 0 is equal to 0, 5 minus 1 is equal to 4, P2 for 14 minus 2 is equal to 2, 12, P3 8 minus 3 is equal to 5, 8 is the service time, 5 is 3 is the arrival time, 8 minus 3 is equal to 5. So we can add the values 0 plus 4 plus 12 5, we are getting 5.25. But in the FCFS we are getting the highest average waiting time. Here we are having the lowest average waiting time. Okay, so that's all about the shortest job. Next we are having the one more scheduling algorithm is called as a priority based scheduling. Here all the process having the priority, based on the priority only we are going to select the process, which process having the highest priority. We have to choose the process first into the CPU. Priority scheduling is a non-preemptive algorithm and one of the most common scheduling algorithm in the batch systems. Each process is assigned in a priority. Process with the highest priority is to be executed first and so on. Processes with the same priority are executed on first come first service basis, because if any two process, three process having the same priority is called as a tie. In that case, we have to apply the FCFS. That means which arrival time is very less, we have to allow that process first. Priority can be decided based on memory requirements, time requirements, or any other resource requirements. Yes, sir. How we are going to fix the priority for the process based on the requirement of the memory, requirement of the time, and resource requirements. Based on that, we are going to assign the priority to all the process. Yes, here we are having the example of the priority based scheduling. Here we are having the process called as a P0, P1, P2, P3. Arrival of time of the that is 0, 1, 2, 3. And additionally, we are having one more column is called as a priority 1, 2, 1, 3. So here we are choosing the process, or here we are selecting the process for the CPU. This the down box is called as considered as a CPU or Gantt chart. Okay, how which process we have to take first. So here you can see the priority, which is the highest priority. 1, 2, 1, 3. 3 for P3. So P3 is the highest priority. So that we have to take the P3. This P3 takes how much time? 6. So 0 to 6. After that, remaining this 3 is that P0, P1, P2, which is the highest priority. P1 is the highest priority because the value is 2. So that we have to take a P2, P1 for 3 milliseconds. So 6 to 9. After that, we are having a two priority P0, P2, both are having the same priority. P0 is also having the same priority 1, and P2 also having the same priority 1. So which process we have to select? In this case, we have to select the process based on the FCFS, which arrival time is less. P0 arrival time is only less 0, so that we have to allow P0 for 5 seconds. After the P0, obviously, and last we are having the P2. P2 takes 8 milliseconds, so 14 to 8, 22 P2. I hope you can understand about this priority based scheduling. So here we have they are introducing one column is called as a priority. Every process has its own priority. So how we have to select the process based on the high priority, which is highest number having the first priority, highest number having the first priority. See the average waiting time. Average waiting time is 6. Average waiting time for this priority based scheduling is 6. Okay. So FCFS completed, shortest job next completed, priority based scheduling also completed. Next we are having shortest remaining time. Shortest remaining time. That means if any one of the process is get into the CPU for particular reason, it comes out to the CPU, but total time of the CPU is 10 milliseconds, means only after the 8 milliseconds are completed, it comes out from the CPU, only 2 minutes are remaining. So based on the remaining time, all the process having some remaining time, based on the remaining time, which process having the less remaining time, which process which process having the less remaining time, that process we have to choose into the CPU is called as the shortest remaining time. Shortest remaining time is the preemptive version of the SJN algorithm. Yes, shortest remaining time is the preemptive version of SJN algorithm. We are having already SJN, shortest job next, that is a non-preemptive. This shortest remaining time is the version of the preemptive with SJN algorithm. The processor is allocated to the job closest to the completion, but it can be preempted by a newer ready job with shorter time to completion. So here we have to select the process. Here we have to select the process very close to complete, very near to close to complete. That process we have to select in this case, which process having the least remaining time. Impossible to implement in interactive systems where required CPU time is not known. Impossible to implement in interactive system where required CPU time is not known. Yes, here also the same thing in SJN. If you don't know about the process burst time or any burst time, we cannot take that process in the SRT. So we must know about the CPU time is CPU time. If the CPU time is not available, we cannot choose the process in the SRT. It is often used in batch environments where short jobs need to give preference. This system is implemented in the batch operating system or batch processing. Because in that batch we are having a more number of jobs. So how we are going to execute the job inside the batch based on that time. Some processes are requesting highest time, some processes are requesting very lowest time, so we have to allow the process those who are having the lowest time first into the CPU, because here they are trying to reduce the size of the queue. If you allow the longest CPU time into the CPU means remaining process is waiting for a long time, so that avoiding that kind of situation is called as a starvation. We have to allow which process having the shortest remaining time, that process we have to allow into the CPU. So that is also possible, that is also one of the main criteria or main thing in the shortest remaining time. Okay, next one, round robin scheduling. The round robin scheduling means round robin is the preemptive process scheduling algorithm. Round robin is preemptive processing scheduling algorithm. It is one of the important thing. One of the scientists, Robin, is invented this method, so that's called as a round robin scheduling. Each process is provided a fixed time to execute. It is called as a quantum. How the quantum is playing in the round robin scheduling, we will see on the next slide. Once a process is executed for a given time period, it is preempted and other process executes for a given time period. Context switching is used to save the states of the preempted process. Yes. A round robin is one of the preemptive method. Say for example, we are having the three process, namely called as a P1, P2, P3. P1 request 5 seconds, P2 request 6 seconds, and P3 request 7 seconds. P1 request 5, P2 request 6, P3 request 7. So here we have to introduce one new thing is called as a quantum time or time slice for all the process. That means all the process going to take the CPU in equal time slice, not based on their total burst time or total CPU time. All the process is going to take the CPU for equal time, so that we have to fix the thing, or we have to introduce the element is called as a quantum or time slice. So they are given the problem along with the time quantum is equal to 2 milliseconds, time quantum is equal to 3 milliseconds or 4 milliseconds like. So in our example, P1 requesting 5, P2 requesting 6 CPU time, P3 requesting 7 seconds as a CPU time. But the time slice or time quantum is equal to 2 milliseconds, means all the process is going to take the CPU for only 2 minutes or 2 seconds. After that, it's preempted. Preempted means what? We are going to remove the process from the CPU. Again, we are going to put the process into the queue again, into the ready queue. So within the 2 second, it should completed maybe 50% of the work or 60% of the work. So again, it's going to stay in the queue. Again, we have to allow one more process called as a P2. The P2 request is 6 milliseconds, but we have to allow the P2 inside the CPU for only 2 milliseconds, because our time slice is equal to 2 milliseconds. So every process is going to take the CPU for 2 milliseconds, because we are mentioned here time quantum is equal to 2 milliseconds means every process is going to reside in the CPU for only 2 milliseconds. After that, we are going to take the process, or we are going to remove the process from the CPU and put the process into ready queue again and again when up to complete its 100% of the job. Up to complete its 100% job. When the process completes its 100%, it can terminate from the CPU, not need to joining in the ready queue. No need to joining in the ready queue. We have to terminate. We have to exit the process from the CPU. That is the biggest thing in the round robin scheduling. Once the process is executed for a given time period, it is preempted and other process exists for a given time period. Yes, once the process is executed in the given time, like time slice is 2 milliseconds means 2 milliseconds. After that, we have to remove the process or preempted the process, and we can allow the new process, other process for their given time, for their given time. And here number of contact switching is made. That means one particular process going to CPU and going to ready queue is happened number of times. Number of times the one process is going into the CPU and going into the ready queue or going into the main memory. It's happened number of times. That's why they have mentioned contact switching is used to save state of the preempted process. Round robin scheduling. Here you can see the example. P0, P1, P2, P3, P2, lot of processes are there. Every process having 5 milliseconds, 8 milliseconds, 9 milliseconds, 11 milliseconds, 20 milliseconds. But we have to allow only one, 3. Here quantum time is 3, so that 0 to 3, 3 to 6, 6 to 9, 9 to 12. After that, this P0 already completed 3 milliseconds. It requires only total 5. So P0 is 3. So remaining 2. So that 12 to 40. 40 to 17, 17 to 30. 3, 3. Every range is 3 because quantum time is 3 or time slice is 3. So once the P0 completed 3 milliseconds, the total time of the P0 is 5. In the first cycle, it's completed 3. The remaining 2 is there. Again, it's going to joining in the queue. When it comes in its turn, it have to complete the remaining 2 milliseconds. 2 milliseconds. So that's why they write 12 to 14. So this is called as a round robin schedule. Round robin scheduling. So the round robin scheduling is very important, and we have to use in many applications this round robin scheduling. So we have to carefully doing this. You will not don't spend more effort to understand about this round robin scheduling. Just they are having introduced one more two things is there. One is a time quantum or time slice, and before understand about the Gantt chart or before understand about the CPU, here they are introduced one more thing is called the ready queue. Ready queue. Every process complete 3 seconds. After that, going to joining in the ready queue. Going to joining in the ready queue. With the help of the ready queue only, we have to solve the round robin scheduling problems. Okay, that's why it's very important. Next and last one is the scheduling algorithms called as a multi-level queue scheduling. Multi-level queue scheduling. So what is multi-level queue scheduling? Multi-level queues are not an independent scheduling algorithm. This is not independent scheduling algorithm like FCFS, like shortest job first, like priority based scheduling, like shortest remaining time, like round robin scheduling. This is not an independent scheduling. This is a dependent scheduling algorithm. How it's dependent? See here. They make use of other existing algorithms to group and schedule jobs with common characteristics. Here we are going to receive more number of process. Here we are going to receive more number of process. Some process is based on the memory. Some process is based on the any kind of requirements, memory or function. A lot of aspects are there. So all the processes are coming into the CPU. On that time, we are going to make the batch, or we are going to make the group based on the common process. Based on the common process, we have to making the group, or we are going to make the different and separate queue. Multiple queues are maintained for a process with common characteristics. So those process having the common characteristics, for that process we have to maintain a separate queue. So here, so that we have to form more number of queues for more number of constraints or more number of characteristics. Each queue can have its own scheduling algorithms. If we are having a three queues or four queues, we have to use whether one queue for FCFS and one queue for shortest remaining time and one queue for round robin schedule. Like that's why they are given each queue can have its own scheduling algorithm. Priorities are assigned to each queue. So we can able to assign the we are having the scope to assign the priority for each and every queue. So that is called as a multiple level queue scheduling. Based on the common characteristics of the process, we have to make the different queue, separate queue. So that we have to form more number of queues. So that's called as a multiple level queue. We have to use different algorithms. Like one queue contains FCFS, we have to allocate SJF to one queue. We have to allocate round robin for one particular queue, and also we can put the priority for each and every queue. That is called as a multiple level queue scheduling. Okay, today in this video we totally covering about the scheduling. What is scheduling? Why we need the scheduling? What is the types of the types of schedulers, long-term scheduler, short-term, mid-term scheduler. And a very important thing is called as a type of scheduling algorithms. So you must know about this type of scheduling algorithms. And in the next video, I have to put about how we have to solve the problems in FCFS, how we have to solve the problem in SJF, how we have to solve the problem in priority based scheduling and round robin scheduling and SRT scheduling and multiple level queue scheduling. That will very helpful to understand about the entire process of how the CPU is working in the operating system. Okay, that's very important. Without the CPU scheduling, we never organizedly working with the process in the computer. So all the process is only working based on the, or all the process only executed only based on the scheduling. Without the scheduling, you never do anything done. Okay, that's all about today's this video about the CPU scheduling. I hope all are understand about the CPU scheduling and the types of CPU scheduling. We will see on the next video. We will see on the next video about the problems of CPU scheduling. Thank you.